Welcome to another video where I show you the making of my electronic project. This time I will show you an idea how you can turn your regular wardrobe into smart system controlling the backlighting of entire furniture and allowing you to organize and manage all your clothes through web or mobile app. I will also try to make some interesting algorithms using weather API, knowledge of what clothes are currently in the wardrobe, using statistics of clothes usage, user localization history, and so on. I have a lot of crazy ideas and I think this project will be really cool. Remember to subscribe if you don't wanna miss next videos about this project, and let's get started. As you can see, I have a lot of parts here. There is ESP32 to control everything, 1.8-inch SPI LCD screen, RFID module and some text for it, limit switches to detect if doors are open, some other electronic parts like connectors, universal circuit board. I also have a lot of cables and LED strip to backlight all my furniture. Here's also a 40 amps 5 volt power supply, and this is WS2812B addressed RGB LED strip on black PCB and some corner connectors for that. That's better. Just some plywood and furniture veneer and we are ready to go. And if you are interested in a more expensive version of this project, I can show you also how to use Raspberry Pi with a much larger touchscreen instead of ESP32. Then we could also play with the sound, for example, communicate some information by voice or use voice control. It's time to show you what the construction looks like. If you are more interested in the tutorial and programming part, it starts at this time. And links to the circuit diagrams and complete code can be found in the description. Power supply you need depends on LED's type and strip length. You should look into auction description or strip datasheet and calculate the required power. Typically, you will find power consumption for 1 meter or single LED. For example, in my strip, single LED consumes about 0.3 watts. Multiply it by 30 LEDs per meter and 16 meters in LED, and we get 144 watts. Divide this by strip working voltage, which is 5 volts for WS2812B, and we get 28.8 amps. You should add about 10 to 20% more and use a power supply that is at least this powerful. For this example, 35 or 40 amps will easily handle entire strip with full brightness. For connecting, use a cable with plug. Inputs are labeled. Connect neutral and load wires, and ground if you use a grounded connection. Next, connect the positive and negative outputs to the circuit and test if everything is working. My electronic setup is done, so it's time to write some code and talk about how it works and how to connect everything together. I will use Visual Studio Code. It's better choice than Arduino IDE, especially if you are really into programming. but you can use Arduino IDE, write the same code and it should work. Okay, let's start with installing Platform IO. It's an extension that will allow us to program ESP32 from VS Code. Wait until the installation is complete and restart IDE. Now we have a new tab here. We want to go to Platforms. In the embedded category, search for Espressif. And install ESP32. Now we are ready to program ESP32 with VS Code. We can go to Home tab and create a new project. Select your ESP board. In my case it's DevKit first version. Select Arduino framework and click Finish. After a while, our new project will be created. And in the src directory we have file main.cpp. And here we will write our code. At the beginning, I will use the Arduino OTA library. It allows to program ESP wirelessly using Wi-Fi. You don't need to connect your computer with a cable. It's useful if the ESP is in hard to reach place. Let's add some imports for that. Next, configure the Wi-Fi connection. You need to pass their SSID and password. I will put it into a separate file. Now initialize Arduino OTA and use it in the loop. There's one more thing I want to configure. If ESP loses Wi-Fi connection, it won't reconnect automatically. We need to handle it manually. Create variables for reconnect interval and time since last connection attempt. And in the loop check Wi-Fi status if it's disconnected, and if enough time has passed since last try. Try again and reset the timer. Now we can move on to using electronic parts. I will start with LED strip. For that I will install NeoPixel library by Adafruit. Connection is easy. There are 3 pins, 2 of them are for the power supply and third is a data pin. Let's define ESP pin connected to the data of LED strip and the total number of LEDs used in the circuit, and create a new instance of LED strip object. The second thing is handling the limit switches for detecting if doors are open. I will use Easy Button library. This will make things easier because we need feature called debounce. ESP is faster than Arduino and it can catch very little bounces and cause it to read multiple button state changes even though it was pressed only once. When it's installed, define pins for buttons and debounce time, and write configuration and conditions for detecting opening or closing of doors. Then we can handle turning on and off LEDs. I'm creating a simple animation for switching it on, but that part very much depends on how and how many LEDs you use.
Another electronic part used in this project is RFID module. We connect it via SPI. LCD display will be also connected via SPI. Connection for both is similar, but you need to pay attention to some differences in labels that can confuse you. For example, SDA in RFID module is chip select pin if you use SPI, while SDA in this LCD display is MOSI pin. These are all connections. For RFID module, I'll use MFRC522 library. Let's start with adding an import, define pins, then just copy the code from the library example and cut out unnecessary parts. I also added a buzzer for informing when tag has been read. So install Tone32 library for that, define pins, and play the sound after reading the tag. The last part is LCD display. I have display working on SPI, and I will use TFT ESPI library for that. The first thing we need to do after installing the library is to find a configuration file in the library directory. It's named user setup h, and we need to change a few things here. Firstly, we need to set the correct driver for our display. You should find it in the auction description or display datasheet. Next, we can define the resolution. And finally, set the proper pinout for our setup. After that, we can go back to our code. Let's create new object instance and add basic configuration for backlighting and rotation. And handle turning on and off backlight when door state changes. In the future, after opening the door, the display will show information about the router. So hardcode something like this for now. Also turn on the LEDs at startup if doors are open. Let's also add displaying a read tag ID on the LCD display. Now, upload the sketch and test it. You can find the complete code and wiring diagrams in the description.
was a lot of work after hours, and it's just a beginning. Now I'm going to continue coding and make the most of this electronic setup. In the next episode, I will show how I create a REST API with Node.js and MongoDB, a web app with React, and integrate it all with this ESP32. You may also wonder what role the RFID sensor plays in it. I didn't say that, but I said that we'll use the knowledge of what clothes are in the wardrobe. And if we put the RFID tag in a clothes, and every time we put it in or take it out, we bring it close to the sensor, we'll get exactly the information we need. Don't miss that episode and other future episodes. You can see the topics of them at the screen right now, and see you soon.